Okay. Okay, I think yesterday we talked about why airfield ratio control important and what airfield ratio you have to maintain for depending upon the situation, correct? Depending upon the situation, what airfield ratio you maintain. Here, situation means throttle condition, correct? What you call driving condition. Driving condition is decided by the driver who is riding the vehicle or driving the vehicle, correct? That depends upon various factors, correct? Depends on age, driving experience, all those things. That's okay. If you want to have good acceleration, you have to maintain rich airfield ratio. That's what I told yesterday, correct? Rich airfield ratio for good drivability. Correct? Better acceleration, all those things. But fuel economy will be very big, will not be good. Fuel economy will not be good. Right? But you will get better acceleration. All those things are possible. Okay, that is one thing. The other thing is if you want better fuel economy, correct? You have to run with linear mixture, correct? This area from this area up to 20, correct? This area is better fuel economy, lean mixture, correct? So you get better mileage, correct? Better mileage, so you can burn less fuel, pollution will be less, all those things, but acceleration will not be good. But I want a balanced solution. And all apart from that, if you run rich or lean, you can see that there are some gases, correct? If you run rich, you can see that HC and CO is high. Rich mixture means HC and CO is high. The NOx is very less. In rich mixture, engine doesn't produce NOx, nitric oxides, at rich mixtures. That means, say for example, 10:1 to 14.7:1 within the range, stoichiometric, that range, especially around 12-13, correct? 12 to 13 airfield ratio. It gives very good acceleration, all those things, but you have to live with higher HC and CO emission, rich mixture, correct? But better drivability. But NOx is less. But if you go to linear mixture, up to some extent, you can see that the HC also is coming down, correct? Up to this, from rich mixture, this area, correct? From 14.7 is to maybe up to 18, HC is less, not zero, it is less compared to this one, around this one. But once we make it still linear, again, irregular combustion happens. You may be wondering, correct? When less fuel is injected, why HC is increasing? You have more air, less fuel. There's no question of this one. But here misfire can happen. Misfiring, correct? Misfiring means since your airfield ratio is greater than 18 to 20, 21 and all, correct? Near the spark plug, if the fuel vapor is not available, correct? Combustion will start. So that time, the entire fuel will be just sent out. That is going to be waste of fuel, correct? That is called as misfiring. Misfiring is not good, correct? So you will not, in that case, unburned fuel is coming. That's what unburned fuel we call as HC regulation, correct? Emission, correct? Hydrocarbon, unburned hydrocarbon, that will go high even in the lean mixture when it is too lean because of misfiring, correct? So because very thin amount of molecules available to start the combustion, even a spark is given, that happen. Otherwise, generally HC will be less. Up to 14 by up to 18, you can see that. But you will see that the NOx emission is very predominant in the range of around 16 airfield ratio, correct? That is lean, best fuel economy. If you run your engine at this point, around 16, 15, 15 to 16, around this, especially this region, you have better combustion, and the fuel economy is high. Fuel economy is high, correct? Because you are injecting less fuel and more oxygen. Most of the fuel molecules will join with oxygen, form H2O and CO2 combustion. So you will get better thermal efficiency also. That is very, very important. Better thermal efficiency when you run engine at lean, not too lean like 18, 19, 20. There misfire can have HC can reduce. But if you run around this number, correct, around this number, correct, this area, correct. So something around 16, correct, plus or minus a few points, correct, say 15.5 to 16.5, something. The best fuel economy, correct, less pollution, correct, and also better thermal efficiency. Okay, so that means this is best point to operate, but may not get answer. But only one drawback of running at lean mixture around this, even though you have better fuel economy, less pollution, correct, less pollution in terms of, you can say the HC and the CO is less, but NOx is very high, correct. The maximum NOx happens when air fuel ratio is maintained around 16. It has many advantages, better fuel economy and thermal efficiency, all those things. Even CO and HC is less, but NOx is very high. Because when better combustion happens, correct? When better combustion happens, what happens is the combustion chamber, correct? The temperature inside the combustion chamber will be high. Combustion temperature will be very high compared to other points, very high. When the combustion temperature is very high, if temperature is high, then more NOx is produced. Correct. So NOx will be produced only when combustion temperature chamber temperature is above 1200 degrees, around 1200 degrees centigrade or above. Correct. When combustion temperature, which is happening inside the combustion chamber, fuel air burning, correct, that time temperature rises. Correct. It will go from 200 degree before combustion to 200 or less than that to around 1200, 1000 also. That during combustion power stroke, when fuel is burning, when the combustion temperature increases around 1200, around and above, correct, the NOx nitric oxide is very high, correct. That happens only during when air fuel ratio is maintained around 60. That's what that you can see the violet color line. That here very small region, the combustion level is very high, correct. Because of that only you have better thermal efficiency. High temperature means more pressure is created, correct. If more pressure is created, more downward piston force is created, correct. So that is converted to torque. That means more torque, correct. All the fuel is burned, and if you burn all the fuel for a given amount of fuel, you get maximum torque, correct. So that is what we say thermal efficiency is very high. But the combustion temperature increases around 1200 and above. So this temperature is very good. I cannot say very good. At this temperature, very high NOx formation happens. NOx, correct? NOx formation happens when temperature is around. Now, if the air fuel ratio is lesser than that, or above this 16.1, still lean, correct? You can see the NOx again falling. Why? NOx is falling, but HC is increasing because misfire is happening, correct? So because lean mixture, you give a spark, combustion doesn't start, correct? So most of the fuel it may start, and because of flame doesn't propagate because very lean air fuel ratio. So the combustion may be quenched, correct? So that means remaining fuel, unburned fuel will come out. So HC start increasing. You can see that beyond this point, 16, HC is increasing because of misfiring, correct? Very lean mixture, correct? One cycle it may fire, next cycle may not fire. All those things can happen. The HC increases. But now misfiring happening means combustion is not happening. What will happen? Combustion temperature reduces. Combustion chamber temperature reduces because every cycle is not firing. Some cycle you are missing. Average temperature of combustion chamber inside combustion chamber reduces, correct? Less than 1200 degree. Automatically NOx formation reduces, correct? Even though lean mixer, because combustion misfiring, all those things, not proper combustion is happening every cycle, HC is increasing, but NOx is coming down. So you should not operate your engine beyond something around beyond 18 or 20, correct? That is the region I marked, correct? This is a region where you can see the 18 to 22 something, more HC, unburned fuel, and less NOx and CO, correct? CO formation also not happening because your fuel quantity is less, correct? More oxygen is available, so that happens. So best thing is to operate your vehicle engine here. Engine, if you want fuel economy, run your engine at lean mixture. This is lean around 60, not exact line, correct? Plus or minus something. If you want best overall emission control, because emission control is not good lean or rich, correct? Lean, you can see the NOx CO is reduced, but HC is very high, correct? But in the 16, NOx also very high, HC also slightly less but high. Only CO is less. But only when run at stoichiometric, all these two are mid position, correct? HC and NO, this one is mid position, NOx, CO is very less, correct? As stoichiometric. So if you want the pollution control, you run at stoichiometric air fuel ratio. If you want more drivability, correct? Better acceleration, run around rich mixture, around 12 to 13, correct? But you are live with higher levels of HC and CO, correct? And rich mixture. So this is how you have to do. Again, if you want to control the tailpipe emission using three-way catalytic converter, TDW, correct? Catalytic converter, correct? Catalytic converter efficiency. You can see that the x-axis is air fuel ratio, y-axis converter efficiency, correct? How much the CO, HC, all those things you converted into CO2, H2 and N2. That is what is this one. That it has, this is start from 0% to this is 10%. For example, this is 10%. Y-axis, correct? You can see that it will be around 90% when you run your engine at stoichiometric air fuel ratio, 14.7:1, and use, but you have to use catalytic converter. If you use the catalytic converter, then the tailpipe emission is reduced around 90%, close to 90% is reduced. Correct? So this is the important key point in petrol engine. Whether you want to control emission, run the engine with stoichiometric air fuel ratio, but attach the three-way catalytic converter in the tailpipe. If you want better fuel economy, run with lean mixture around 16, and you will get better thermal efficiency, better fuel economy, all those things, but less drivability, little. What you will get? No, I want better drivability. I'm not worried about fuel consumption. Okay, then you go to rich mixture, you'll get better drivability, which is around something 11 to 13 something, correct? Around 13, 11 to 13. 12 is the midpoint approximately. And but you have to live with higher CO and HC, correct? So you have to operate, you have to design. Okay. So now we'll whatever I discussed the last two classes, we are doing. Now coming back to fuel injection, there are three types of fuel injection control is there. Correct. We know that we are talking about fourth fuel injection. Correct. Fourth fuel injection, which is called as PFI. Right. So in the port fuel injection, there are yesterday I told you, one is simplest method, N-alpha method. In N-alpha method, you are using lookup tables. Correct. Lookup table you have to create in the laboratory condition or in the test cells. In the company will make the maps by running the engine at different throttle positions, different speed, and varying the fuel injection quantity by varying the pulse width. Correct. The pulse width, injection pulse width. Injection pulse width is varied within some range, correct? Start with injection pulse width as a DC type, say for example, 1 millisecond, I say a single cylinder engine, try to increase 1.1, 1.2, something like that, go on increase. For some pulse width, you will see that engine torque will start increasing from some minimal value and go to the peak value, start reducing. This may be, for example, 1.4 millisecond at, for example, say 2000 RPM, I'm talking 2000 RPM and say 10% throttle. Correct. So how did you find out? You vary the fuel injection by programming your ECU to vary the injection, the pulse given to injector. Correct. This is 12 volt pulse given to fuel injection. This is called, so we call a pulse width model, PWM pulse. This is called a PWM pulse because I am varying the, this is called as on time. Correct. Pulse on time. It is called as pulse on time. That will be increased from your small value. Okay, can you, why not, somebody may ask question, sir, can I start the pulse width with 0 millisecond? No, because another one more thing also, what you have is injector dead time. Injector dead time is there. Correct? So what is the injector dead time? We know that the injector already told you it is a solenoid, correct? Electromagnet. So it is an inductor, correct? Inductor with resistance, because coil is made of inductance with resistance. So it is called a RL circuit. RL circuit is represented by, this is your injector, equivalent circuit, correct? Resistance and inductor, coil, correct? It has inductance, this one. Together they form what is a first order system. It is called as first order system, electrical system. When if we give a pulse, correct? For a first order system, if you give a pulse, because it was 0 volts, correct? At time t equal to, this was 0 volts, correct? This is 0 volt, this is 12 volts. Suddenly gave a pulse, correct? And then when I give it, this is voltage pulse. When I give a voltage pulse for this, what will happen is the current will start flowing, correct? So I am applying a volt, correct? 12 volts here, plus minus to injector. So there's a current flow I. How the current flow will be there? Current will not flow immediately. Correct? Being inductor in first order circuit, there is a resistance for sudden flow of the current. The inductor always opposes sudden change of current. Correct? So because of that, even though I give this one, the current will start increasing like this, exponentially. Correct? This will start increasing. This is I. Right? So that I, the rate at which the current is increasing, called as time constant. They called as time constant of the injector. Correct? Because this is a RL circuit. The correct that depends on resistance inductance value. Correct? The time constant is proportional to resistance and inductance value. Correct? So if you more inductance, less resistance, it takes longer time to charge. So that means you will get different time constant like this. Correct? Because of that current, because we know that this is time axis, correct? This is time axis. This is 0 second, 1 millisecond, correct? Say I say the 2 millisecond. If I give a smaller pulse, the current, if the time constant is too large, correct? Time constant too large, that depends upon wire thickness in the injector coil. No, there's a coil is there. The wire thickness, number of turns, the length of the injector coil, all these things decides the L value. That is called inductance value. Resistance is wire material and wire cross-sectional area. It is a solid wire, copper wire. So that decides resistance. The ratio decides the time constant. Correct? If bigger time constant, even though given a pulse at t equals 0, 12 volt pulse, yeah, constant pulse is given for 1 millisecond, the current will rise like this. I can see the bottom modes. This will correct. Larger time constant. If the time constant less, it can current will rise quickly. Like that. So if we give a smaller pulse width, suppose if the time constant is large, correct, what will happen is the current will not reach the peak value. Correct. So this is the current. Correct. Current is varying from 0 to, for example, 3 amps. Correct. So this is 1 amps, this is 2 amps, this is 3 amps. So if time constant do that, the current flowing to inductor is only 1 amps. Correct. 1 amps, when 1 amps current is flowing to the circuit. Correct. 1 amps current is flowing to circuit, the magnetic field created by the coil may be less. Correct? So it will not open the injector. Correct? So injector, so we saw that injector is as an electromagnet. Correct? This is an electromagnet. You have, this is the coil. Correct? This coil only I am giving 12 volt pulse. A pulse like this. Correct? 12 volt pulse I am giving. This is 1 millisecond duration. Now, the current I is flowing, the electromagnet is produced. Correct? It has to push the plunger up, then only the field will come out. Correct? So, if I give a smaller pulse width, if the injector time constant tau, correct? Generally, time constant tau is, for example, 1 millisecond, and I give 1 millisecond, this duration is 1 millisecond. This duration is 1 millisecond. Current may rise like this. Correct? So, I want a peak current here. Peak current here, so for example 3 amps, it reaches only 1.5 amps, for example, because of higher time constant. Correct? It will be generally in milliseconds. I say that my time constant 1 millisecond. So that means it may reach very slowly. So the electromagnetic force produced by the magnet will not be sufficient to pull the plunger up. So fuel will not be injected. So that is called a dead time. Well, injector dead time. But how do you know? You can test the experiment. You can connect the injector to your 12 volt pulse using a pulse generator. You can use a pulse generator, correct, which can generate 12 volt pulse. Correct? 12 volt is the pulse maximum, because pulse is always 0 volts, suddenly it goes to 12 volts and remains on 12 volts for some time. This is 12 volt, this is 0 volt, this is my time axis. Correct? So this is 0 time. So I give 1 millisecond. You can make it for say 1.2 millisecond. correct? So you give the pulse, 1 millisecond pulse, and see whether injector is opening. You connect the injector to the fuel pump, all those things. But please see that don't put finger near the injector outlet, correct? Here the pressure is 5 bar, correct? The fuel pressure is 5 bar. The nozzle coming out of 5 bar pressure. But if you put the finger near that, correct, the petrol can penetrate your skin and go inside bloodstream. But this is very low. But don't do it in diesel injector, correct? In diesel injector, fuel is pressurized to 1000 CRDA engine. CRDA injector is injector we are going to see today. There also you have injector. There the pressure is 1500 bar. Latest is 2000 bar. Correct? While testing the CRD injector, you need a separate enclosure not to go near that, because the fuel is coming out at 1500. You won't even have know that the fuel, if you put your finger or body near the jet, correct? So the diesel fuel will go inside in your body, correct? And you won't even notice. It will be a painless injector, but you know that injecting diesel is highly dangerous. If it enters the bloodstream, brain, everything will be swollen. So never go near the fuel injector of CRD engine testing, correct? Well, near the nozzle. That is very important, correct? Sometimes students do research scholar without their knowing. They don't know the consequences. You won't even have the pain. At least if you put a needle, injector, go to for a doctor, you put an injection. At least you have the pricking pain. Here you won't even have that, because the fuel is coming at like a mist, 5 micron or diameter something at 1500 bar, 2000 bar. It just is penetrating, deeply penetrating into bloodstream and blood vessel and muscle. You can't remove diesel from your body. That is not so easy. Correct? Be careful when you talk with injector handling. Never show your hand, put your body close to injector nozzles, especially CRD engine. Okay. Generally, put it at the enclosure. Close the enclosure, they do testing. But in your laboratory, as a research scholar, you should not do. Because I work in IC engine lab, the students are working CRD engine. Right? So might be that's why I'm just advice. So now the time constant plays a vital role. If the time constant too high, the current will increase like this. Correct? It may not reach the peak value. Correct? If time constant too high, I will see in red color light. It may reach. So this is the current. This is voltage scale. Other only I say the current scale. Current 0, 1 amps, 2 amps, and 3 amps. Correct? So now the current reaches only 1 amps because high time constant. So that means the magnetic force created is not sufficient to pull the plunger out, make the fuel come out. So it is called dead time. How will you find out? As I told you, connect to injector, this one fuel pump, injector, and give a pulse to the pulse generator. Then increase the pulse width. 1 millisecond injector not opening, then what you have to do? You have to give 1.2 millisecond or 1.4 millisecond. Then you give only one pulse. You have to see just one pulse, not continuous pulse. Then you see injector. So if injector opens, I know that the current has reached here like this. Correct? So the current has gone to maximum injector current. So injector rating, they will say 12 volts, 3 amps current. Now, if you buy an injector, you have to see what is the voltage operation, what is the current needed for drive the injector to fully open. Fully open condition only fuel will come. It is on-off control, correct? Injector is on-off control. It is not a proportional control, open in between some amount of fuel. If you do that, the mist will not be formed, correct? Atomization will not happen. So you have to see that you always do the current, proper current, supply proper current. So then, even if you supply 12 volts, because you cannot change the current. It is a fundamental, how much current it is accepting is a fundamental character. So voltage you can give to this one, correct? Coil. You can give coil voltage, but how much current it takes depends upon R and L value. R and L value depends upon number of turns. I say inductance value and the resistance of the injector coil, this coil, correct? That already manufacturer made. He will give the injector character like this graphs, correct? Dead time, all this thing will say. Suppose if the manufacturer 1.2 millisecond dead time, that means the injector, you have to give minimum 1.2 millisecond to open, but that is of no use, correct? You have to give more time than only injector will give. So you have to calibrate. So we are doing that, okay? So, okay, now you open the injector, correct? This is an open loop control, and the open loop control, yesterday we had talked about table, making table, connectivity dynamometer. Did we discuss about that?
Yes, sir.
Yeah. So you make a two-dimensional table, I told you, correct? Top is the percentage of throttle, 10%, 20%, 30 something, it goes up to 100% opening. Why this RPM, correct? Engine RPM, starting with, for example, 2000 RPM, 3000 RPM, 4000 RPM, correct? 600 RPM, make a table, correct? Conduct experiment, fill the injector opening time. See, it is filled with injector opening time at various speed, all this thing. If you do that, that is called N alpha method. It is very simple. You need only two sensors, engine speed sensor and also throttle position sensor. By using that, you have already made this map at test bed, not on the actual vehicle. You have to do this and store it inside your map. So it is inaccurate when there is no correction of in-depth temperature raise. I told you, correct? When temperature increases beyond some value, correct? Whatever the table you create is not accurate. This is called calibration table or fuel map, correct? Or lookup table. This is not valid when the surrounding temperature is not same as what the calibration temperature is when you made the table, correct? So that means you need to make different table for different temperature, correct? That's why inside your ECU, you will not have one table. You may have 20, 30, 40 tables, correct? So for this is 30-degree table, correct? At 30 degree, this is throttle percentage, correct? 20 something, it goes on to 10% and RPM, 2000 RPM. I am talking a single cylinder, 3000, 4000. I go to say 6000 or 8000 RPM, the table extent. I made for what? For at 30-degree temperature. Then what I do, in the test cell, I told you in a company, in test cell, you can, because the entire engine, correct? Engine, dynamometer, everything is put inside your room, correct? It is enclosed. Engine, dynamometer, all those things. Here, temperature, correct? Pressure, air pressure. I'm talking about air pressure, humidity, correct? Air flow rate, what air is coming in, what air, everything is going to the test. This is called test cell, correct? It is called as test cell in company, correct? To build this test cell, you won't believe it will be 5 to 6 crores, 5 to 6 or 10 crore rupee, Indian rupee, one test cell. Why? Not only you have to control temperature, all those things. The room is not small, like this one. It will be normal, something around 6 feet by 8 feet by some 10 feet height, correct? So you will have exhaust, air conditioner, because then airflow control, correct? Humidity control, all those things. Apart from, you have the dynamometer, correct? Dynamometer with lot of sensors, correct? Fuel measuring sensors, air temperature sensors, throttle position, all those things, and exhaust gas analyzer. Exhaust gas analyzer, which measures HCCO, NOx, is called exhaust gas analyzer, correct? Exhaust gas analyzer, which can measure all this one from ppm, so almost from the 1 to 4000 ppm NOx, correct? Similarly, 0 ppm to some 300 ppm of HC, and CO, carbon monoxide, from 0% some to 10%. It can measure exhaust gas analyzer. The cost, you won't know. The latest, this one is around 1 to 1.5 crore. One equipment alone, Indian, correct? So the total test cell is around 10 crore. If you go to big company, because I visited many companies, for example, Bajaj, Tata Motors, Mahindra, they have test cells 10 or 20, because each production vehicle has to be tested before sending out. So they test at least samples. Every 10 engine ones, put in dynamo, 100 engine ones, they test it, because they're selling millions of vehicles per year, correct? So they test all those things. So they create. So they can create any temperature happening at Chennai at atmospheric 1 bar sea level, correct? Or in Ooty, Himalaya, Alpines, correct? Because they're selling vehicles throughout the world, correct? During the test cell, they can create the environment available in the world. Even Antarctica temperature, if you want, you can create. But they're because generally not done, right? They sold this one. You can create minus 40 degree to plus 60 degree, correct? Desert temperature, all those things, correct? Climate condition, and create map. So at 30 degree, 1 bar pressure, correct? And you create one table. So if you run your engine at 30 degree, when the vehicle are driven in the road, correct? At 30 degree temperature, sea level in Chennai, early morning, in Vizag, or in Kochi, or in Bombay, sea level, correct? When temperature around early morning, whatever map you created a test cell for running engine for 1 hour, 2 hour, each this one you filled, no? Take 5 minutes something, that is valid. But suddenly you start from Chennai, I start going towards Coimbatore, correct? As I go towards the inland, the elevation increases. Land is not flat in Tamil Nadu itself. You may think it is flat, but height is increased, slowly increasing. So this one pressure will reduce from 1 bar, it becomes less. As you go to elevated, higher altitudes, you deserve. If you go to Ooty, it is around 1,500 meter, correct? Height from the sea level. So there it may be 0.7 bar, 0.7. So the fuel air map, correct? The map I created is useless. Even though, again, when you go up, pressure reduces, also temperature. Ooty is cold because if you go to higher atmosphere height, you know that the pressure reduces, atmosphere pressure reduces from 1 bar, and also temperature also. That's why we go to summer, go to summer resort, right? Ooty, Kodaikanal, Shimla, all these places, correct? So that means this map is not valid. So what the company will do? They will create a 31 degree. 32 degree, or maybe 35 degree, or 32 degree, correct? So 40 degree, 45 degree at 1 bar, correct? So even at 30, 35, 40, 45, say 50 degree desert condition, 5 maps at 1 bar, correct? 1 bar temperature. So already you have 5 maps. Then you change change the pressure. Say for example 0.8 bar, not 2 bar, because pressure is not going to increase in the earth. Correct? As you go up, suppose your vehicle goes in deep valleys, correct? Deep valleys in which is the depth is lower than the sea level, the pressure can become 1.1 bar, something like that. Mining equipments, correct? So you know the mining equipments, gold mine, all those 1 kilometer deep. There you have the excavators run by diesel and all those things. You create a map, correct? Diesel engine also you have to create like a petrol engine, fuel injection map, open loop control. Correct. So those map is not valid because under the mines deeper, you go 500 meter, 1,000 meter coal mines, gold mine, or the diamond mines. They go up to 1.5 kilometer deep. There they use earth moving equipments run by diesel engine. So there pressure can go for 1.2 or 1.4 bar. Correct. So for that also this valid. So that means for each temperature, each pressure condition, correct, you have to create lot of maps. In engine ECU, if you use N, this is called N alpha method. Here, N is called the engine speed, correct? And alpha is called throttle angle. Throttle angle is alpha. So, since you are controlling with 2 sensors, one is throttle position, is engine speed sensor. Please note that these 2 sensors should be put on the actual vehicle, correct? So, from the ECU will read this speed and throttle position, and it will select appropriate map because it will also read temperature, correct? Atmospheric temperature, atmospheric pressure, correct? They will put to this one, or indirectly you can measure. Correct? There are many ways are there. So anyway, you have to measure. Based on that, the ECU will select appropriate table. From that, we use the engine speed information coming from engine speed sensor and throttle position sensor. It will open the injector accordingly. That's how this works. This is one of the cheapest, simplest method used for vehicle control. This is most widely used in if your vehicle is a low-cost vehicle, 2-wheelers. Now 2-wheelers also coming on. So for example, Bajaj, Pulsar, Yamaha, Honda. So 300cc, 200cc, Triumph. For example, you talk Enfield. All these companies, even 2-wheelers, are come up with last 5 to 6 years with fuel injection. Correct? They call correct FI. There they use N alpha method only. Right. So next month is called what you call speed density method. Correct. This is very simple, but you have to create lot of tables. Correct. That means you have to run the engine at a company for months together to create all the maps. Correct. And store it. But lot of tables you have to create, but a simple controller. Correct. It is a simple controller. The ECU can be simple 8-bit microcontroller. Correct. What it has to do, it has to read the table only. There's no calculation needed. Correct. This XY table, it reads the sensor data based on the read the value stored in the table. For that, you don't need a powerful computer. Correct. Simple 8-bit microcontroller. So cost also less. ECU cost will be less. But only thing is you have to create a lot of tables. Time consuming. Correct. But it is also not whatever you do the correction temperature, still it is not very accurate. In between, somebody asked yesterday, correct? If the value is between this is say 2000 RPM and this is 3000 RPM and this is 10% throttle. If we have value 2.5 millisecond, for example 3.5 millisecond, only for these two values. If I run the engine at 2500 What should be fuel injection opening time? Injector opening time, you in between, correct? We know that 2.5 in between value, correct? You have to go for 3 milliseconds, correct? 3 million in between, how? There's no table, it is do a interpolation, linear interpolation. The ECU has to do that. ECU will read this value, it knows that the current engine speed is 2500 RPM, which is not in the table, but it's not the points, grid points. This is called as a grid points. Correct? In the table, they call it grid point. What is grid point? You have a grid point for 2000 RPM, 10% throttle. This is the next table value, correct? So this is same thing, 3000 RPM, same 10% throttle. Like that, you have grid points. The cells are nothing but grid points. If you go to industry interview, don't get stunned. Correct? Somebody, do you know grid point or lookup table? Grid point, this is the industry terminology. Correct? So grid point, in between means you have to interpolate. In between, you have to interpolate. Any value, you do linear interpolation. Otherwise, if you want very accurate control, you have to take more number of points. So that's not possible. So next method is what we call speed density method. In speed density method, a lookup table based with correction. Additionally, you have to measure air apart from speed, correct? You measure load also, correct? Engine load also, correct? Amount of air to be, fuel to be sent inside depends upon the mass of the air, correct? Mass of the air depends upon load, correct? How much air is sucked in depends also load also. If you are driving vehicle in a flat road, correct? Your vehicle is driven on a flat road, correct? Okay, suddenly you get this one, for example, a bridge, long bridge or a ghat route, correct? So vehicle is climbing, there's a slope, correct? That means there's a load acting on the vehicle, correct? Load, this is normal load, depends upon weight of the vehicle. When it goes, you know that because the slope also put additional load, correct? How will you measure the load? Load can be measured by measuring the manifold inlet pressure, correct? Load can be measured using manifold vacuum sensor, which is called MAP sensor. This is nothing but, MAP is nothing but manifold absolute pressure sensor. Absolute pressure sensor, correct? Short form is MAP. They call it MAP, correct? It is not like world globe map, all those things. Not the fuel map, correct? This also they call it a map, correct? This map is not this short form of the manifold absolute pressure sensor. Where they attach that, I will show you, correct? This place, they put the map sensor. See, you can do a simplest kind of N alpha. What do you have? Throttle position sensor and also engine RPM sensor. Correct? You have to create a lot of maps. I want still accurate control because when vehicle is going in slow, load increases, or put heavy load. Empty vehicle, more load suddenly. As the vehicle was going, when you did calibration, all those things, correct? Empty, unladen load. Now you put load for a truck, normally maybe 2 ton weight or 3 ton. Then you add another 7 or 8 ton load. Correct? Then when the same flat rate goes, more fuel is needed. Correct? The more vacuum is created. That is load. How will you measure? You put the map sensor at here. When more load happens, the air is going, air is going in. Why? Because when the piston is going down, there is a vacuum created. Correct? When piston goes down, when the inlet valve is open, outlet valve is closed, correct? There's a vacuum created. So air is coming through atmosphere, through air filter, throttle control, all this thing enters here, correct? The mass of the air going inside the combustion chamber, vacuum, depends upon how much vacuum is created, correct? How much vacuum created depends upon the volume at rate at which the piston also depend upon the load. Correct? If load is more vacuum is created. Correct? Then more fuel, more air goes in. Correct? More air goes in when more vacuum is there. So in that case, you have to inject more fuel. How do you know? Using map sensor. You put a map sensor in addition to the TPS sensor, throttle position sensor, which measures amount of the air. TPS sensor measure, please note that not measures mass. It measures volume of the air only. Correct? Volume of the air only. How you are measuring? Use the throttle equation. I will show you the throttle equation. Correct? So you know how much, you know the diameter of the throttle tube, correct? Is a pipe, correct? In which the butterfly valve is opening some degree, correct? So if you open, that is theta, correct? Or we call it alpha, correct? Alpha is nothing but throttle angle opening. Fully closed, or it open 1 degree, 2 degree, it can go up to 90 degree. the alpha value throttle opening start from 0 to 90 degree, correct? So fully open condition, 90 degree open, 0 means, so this value you have to substitute in the throttle equation, correct? Diameter, all these things already in the equation I showed that. You could now itself will see. Okay. So using the TPS sensor, you can measure air volume only. But we know that what is the air fuel ratio? Is mass of the air divided by mass of the fuel. Mass of air divided by mass of the fuel, not volume. So, but throttle position gives only the volume. That's why N alpha method is not correct. Correct? Controlling air fuel using N alpha method is not accurate. You are not measuring air. Air fuel ratio, you are doing all using a maps. In between value, temperature, all these things, you cannot give you infinite number of maps, correct? So creating maps, so I told you maybe 20, 30 different conditions, you store it, but it is not accurate. So N alpha method is not very accurate, but it is simple. If it is a simple control and less cost, and you are not too much worried about very accurately controlled, then you can use N alpha method for air fuel ratio control. But it is a open loop control. Correct? N alpha method is also open loop control. No feedback is given. You are not measuring air fuel ratio. Correct? Your table, if I run, what you says, your lookup table map says that if I run the throttle this opening, this much engine speed, if I inject this much quantity of fuel, the air fuel ratio is, say for example, stoichiometric air fuel ratio. That you calibrated laboratory condition 30 degree 1 bar temperature. But if temperature changes, it is invalid. The table is invalid. Correct? But around the value 30 degree 1 bar plus say 31 degree 1.1 bar, 1.05 bar or 0.99 bar. Okay, there's an error. Please note the error. It is acceptable because you are not worried too much. Correct? So that's why you have multiple tables. But multiple tables are too difficult. Correct? So you cannot create infinite number of tables to accurate control. But now, if you want to Bharat 6 control, correct? Emission norms, if your vehicle has to adapt, it has to go to still accurate. N alpha may not be sufficient. Even Bharat 4 result has the difficult, that's why the other method was shown here. Okay, so you put map sensor, the map sensor also will be connected to ECU. Correct? So it knows that based on the pressure, it knows how much air is sucked in, because when vehicle is loaded more heavily, it sucks more air. More air, vacuum is created, more air is sucked. And if you measure how much vacuum is created using manifold absolute pressure sensor, correct? From that, you can always show that, okay, more air is gone, I have to inject more fuel. So you have to do what you call a correction, correct? I told you, if I run my engine at 2000 RPM, correct? And 10% throttle, I have to open my injector for 1.5 millisecond. If I open my 1.5 millisecond, fuel inject is 1.5 milligrams, for example. Correct? And now I wanted to maintain, what is the air fuel ratio I wanted to maintain? Stoichiometric, 14.7. Correct? For that, the calibration is already we are done. Correct? So 14.7, I have to inject 1.5 milligrams of fuel. Correct? So when the throttle, this is open, we are not measured mass. Correct? We are not measured mass, we just calibrate in the laboratory condition. Okay? Now, if temperature becomes high, air density, we know that PV equal to nRT, correct? Ideal air gas, correct? So where pressure, volume, and this is the constants, and of course this is the temperature, correct? Temperature, atmospheric temperature varies. So now we need to measure temperature also. If you want to control accurately, you have to measure temperature also. Apart from measuring engine speed, throttle position, TPS, then you have to put a map sensor to measure what is pressure. So you can still accurately control instead of single, just to TPS and speed sensor alone, which is N alpha method. You can measure inlet air pressure. Then you can add additional fuel quantity, because you know that when the vehicle load is increased or engine load is increased, it sucked more air. That how much air sucked you can calibrate using map sensor. Again, you attach map sensor, load the engine with different loading and dynamometer, and you can measure the map sensor. Then you put a sensor which measures amount of the mass went inside in the lab, correct? Air mass sensor, correct? You measure that and you can add additional correction. Then similarly, the inlet temperature also matters. So generally what they do is, here they measure temperature, inlet air temperature, using a temperature sensor, inlet air temperature. They do this. So if temperature varies, again you calibrate. So these are things which is added in this method, correct? Speed density method, correct? Air density varies depending on temperature. So you need to ECU calculates air flow requirement by referring much larger distance apart from N alpha. Additionally, pre-programmed lookup table, a map of 1,000 values should be equals to engine volumetric efficiency under varying condition, correct? Throttle. How? By measuring temperature, air density, correct? Temperature is measured. So inlet air temperature, they call it IAT. If you see IC engine people, automobile company, the sensor is called IAT sensor, like TPS, throttle position sensor. Throttle position sensor, IAT is inlet air temperature sensor. MAP sensor, MAP, manifold absolute pressure sensor. This is a pressure sensor, correct? This is air temperature. This is throttle position. All these things are used for correcting the N alpha table. That is called as a speed density method, correct? You have additional correction if inlet temperature changes. If you have additional correction, so you have 2.5 millisecond, correct? I said for this one at 30 degree, correct? At particular. Now load increases means you have to inject more fuel. You may multiply this with some constants, correct? Proportional to map sensor. Some constant, I say map correction, correct? Some value multiply, correct? Then if temperature changes, again correction for temperature. Again one more constant, correction for temp, correct? So 2.5 is the base. This is called base table, which is created N alpha method. Then you multiply it with map sensor, correct? Measure the manifold absolute pressure sensor. For the already laboratory, you would have found this correction value, correct? Multiplication factor by conducting experiment different load conditions. Similarly, for different temperature condition, you find a correction table. So the base value for the same load, correct? 2000 RPM, 10% throttle, base value is 2.5 millisecond, but you multiply it with corrections. So if you do that, that is called as speed density method, because this density measure air density, correct? Air density changes when temperature changes. So you need to measure inlet air temperature using IAT sensor in addition to throttle position, engine speed, and use pressure sensor, MAP, manifold absolute pressure sensor. This is used to put a correction factor with the base value, multiplication value by measuring inlet manifold pressure at near the inlet port, correct? Near the inlet port, correct? Here. So this is the second best method, but still that is not correct. If you want actual airfield ratio control, already I told you airfield ratio is always is nothing but proportional to mass of the air divided by mass of the fuel, correct? So best method is measuring the mass of the air itself, mass of air entering into cylinder during suction stroke. Suction stroke should be measured using a special sensor which is called as air mass sensor. Air mass sensor. This sensor directly measures the amount of air entering, not the volume. If you have an air mass sensor, you don't need IAT. IAT is not needed because we are directly measuring. You don't need TPS, throttle position sensor, not needed. Of course, you may need map sensor, correct? So to need the map sensor to correction for the load condition, engine loaded, correct? So you don't need TPS, you don't need IAT. These two sensors can this one, because TPS sensor gives volume, this gives a temperature, correct? These two sensors. In that case, you don't need air mass sensor. Another one more thing is air mass sensor 20 times costlier. 20 times costlier compared to TPS, and at least 5 times. I can say that at least 5 times costlier. Minimum 5 to 20 depending upon company, correct? 5 no, at least 10 to 20 times costlier, because air mass sensor costs something around 5,000, 10,000 rupees something, correct? TPS sensor may be available for 500 rupees. This inlet air temperature, IAT, inlet air temperature may be costing around maybe 100 rupees, correct? Together, you may get it for two-wheeler, maybe OEM level, some 600 rupees. But the air mass sensor may be around 6 to 10,000 rupees minimum. Correct? So very expensive, but it is very accurate because in this case, mass flow sensor, correct, or air mass sensor measure the amount of air mass entering into the engine directly, single sensor, correct? Once mass is something, AFR, air fuel ratio, is nothing but the mass of the air divided by mass of the fuel, right? Now, I want to maintain 14.7. That's why I feel stoichiometric. You know that 14.7 equal to mass of the, you have to design, correct? So your numerator is air mass, correct? That is measured using sensor. Air mass is measured directly using sensor, correct? Say, for example, air mass says that it has a 10 grams of air. The sensor, air mass sensor says directly measures mass, not volume, 10 grams, correct? Now, what should be the fuel quantity, correct? Fuel mass, we know that fuel mass is nothing but, because fuel mass is in the denominator, correct? So this is X. So I can say that X equal to, correct? So this X is coming here, correct? 10 divided by 14.7, correct? So this EC will calculate this will X, correct? So this is fuel mass. That already your injector know, correct? If I open the injector for 1 millisecond, correct? I say that one gram of fuel is opening, correct? So accordingly, because this will be lesser than 1 millisecond, correct? In that case, you may have to open for something around 0.7 milliseconds, correct? So if I open injector for 0.5 millisecond, I will be injecting this much of fuel, 10 divided by 14.7 fuel. So I can maintain the air fuel ratio of 14.7 stoichiometry. That's how the air mass sensor works. This is the best method, correct? For that, what they use it, the sensor used the air mass hot wire anemometer is sensor, correct? It is very expensive compared to IA, this one, TPS, IAT together, correct? But here air mass sensor also include built-in temperature sensor. So these are three different methods used. But if the low-cost vehicle, correct, simplest N alpha, slightly medium range vehicles, if you buy it, you may use speed density method, all these things. But high-end vehicle, BMW, all these things, they are using air mass sensor, correct? Which is buying 30 lakhs, 40 lakh, 1 crore, they use this one. Very accurate control. I stop here. Next class, we will see. Because whatever I explained is there in the slides. I will show all those things. Okay. Next class. So this is very, very important for unless you understand how the engine is controlled, you cannot make autonomous vehicle. This is one of the most important. Of the autonomous vehicle, the other things are there. Sensors, radar, lidar, that also we'll discuss. Other path planning, all those things. But the vehicle also very important. That's why I'm spending more time. Right. So this was the fuel map I created by my PhD work. Correct. This fuel map shows that what I created, this is exactly what was for my vehicle when I did in 2003. Correct. So I stop here. In the next class, we'll continue. Any questions?
Yes, sir. Sir,
Yeah.
I have one question.
Yeah.
Sir, what is this lambda sensor, sir? Lambda sensor.
Lambda sensor is a closed loop air control. We will be seeing it. That is for controlling air fuel ratio closely. See, all these things, all three methods are open loop control. You are not measuring the actual air fuel ratio.
Okay.
So now if you wanted to control, correct? You wanted to control. Okay. If you wanted to control air fuel closely, you need to measure actual air fuel ratio. For that, you have to use lambda control, lambda sensor, which is called EGO sensor. That is for closed loop control. Okay. We will talk about in next class.
Okay, sir. Right.
Okay. Thank you.
Thank you.